Hi guys, I'm going to do a little bit more on circuits right now. Now tell me, Alessandro Volta is the first gentleman who developed a battery. How did he feel when he developed a battery? Shocked. Right, yeah, here's the circuit. And I'm going to put in this time an ammeter. I'll talk about that in a second. And I'm going to put in a couple of globes. I could draw that as resistors or as globes. I'm drawing it as globes this time. And I'm just completing the circuit. Now I'm going to put in a couple of voltmeters this time. I'm going to call this V1. And I'm going to call this V2. I'm going to say this is a 4 ohm resistor and this is a 2 ohm resistor, and we're going to have a 24 volt battery. Now current flows this way through the ammeter first this time. Ammeter, that's an ammeter. You can think of it as being an amp meter. It measures amps or current. What's current? I hear your brain's ticking over. The rate of flow of charge, how much charge flows per second. Now ammeters are considered to have near zero resistance. We don't want them reducing the current in the circuit. We put them in series. Ammeters are connected in series. But because they've got near zero resistance, they don't add significantly to the resistance of the circuit, and therefore they don't reduce the current drawn from the battery. Voltmeters, on the other hand, there's a voltmeter. They're connected in parallel. So voltmeters have almost infinite, that's the sign for infinity, almost infinite resistance, very large resistance. They take very little current, just enough to measure the voltage. So they don't affect the resistor that they're connected in parallel to. They just take a very small amount of current, and they measure the voltage. They actually measure voltage, and we call that potential drop. So they measure the potential drop. There's a certain amount of energy available there. There's less amount of energy available here. Why is that? It's taken energy to push the current through this resistor. So there's a potential drop. Potential is the energy you've got. There's a potential drop, a drop in energy. Potential drop, or a drop in available energy. There's another potential drop here. Those potential drops should add up to 24 volts. The total amount of energy available for the circuit is 24 volts. This takes a certain amount, this takes a certain amount, and we're going to have a look at how much that is in just a second. So let's do some calculations. This gets a little more difficult, so you'll have to focus. Okay, so what's the total resistance of the circle? Number one, what's the R total for the circuit? Equals R1 plus R2. You're probably ahead of me by now. 4, whoops, that's an equal sign. 4 plus 2 equals 6 ohms. Number two, what's the current? Current drawn from the battery? This is your total current. What's your current? Well, that is the current. I'm just going to say total. It's V on R. I won't always say total current. It's V on R, so 24 over 6 equals 6 ohms. 6 amps. 6 amps. I need an audience. I'll do a lot better with an audience. I need to have all your kids out the front there talking so I can tell you to be quiet. I'll have to start telling you to be quiet. Means I've got to remember your names. That's hard. Especially when I can't see you. Okay, so 6 amps is drawn from the battery. The ammeter reads 6 amps. It reads 6 amps. 6 amps through here, 6 amps, 6 amps, all the way around, 6 amps. What's V1? We want to know how much energy per unit charge does that 4 ohm resistor, how much energy per unit charge does this resistor use? Well, we always use V equals IR. What's the current through that resistor? 6. What's the resistor? 4. I'm going to start this again. Why didn't you yell out at me? Someone should. No, I'm not going to start again. Look, I made a mistake. That's 4. I know you all yelled and screamed at me at home, but there we go. I was getting the wrong answer here. There we go. Thanks for yelling and screaming at me. Now you need to yell a little louder. I didn't hear. I'm getting old and deaf. So next time I do that, yell a little louder. I didn't do that on purpose, although I could have pretended to. This is going to be 4 times 4. 4 amps. This is 4 amps. I hear you yelling at me. This is 4 amps. I hear you yelling at me. I'm going to do another one of these to fix it all up. I'm going to show you this one though. IR, 4 times 4, so that's 16 volts. Now that's V1. Now V2 is I, this is R1. I, R2, this is R1, this is R2. So that's 4 times R2, which is 2, which is 8 volts. Now, guess what? 16 plus 8, thank goodness, is 24 volts. The total potential drop across the circuit has got to be the EMF of the battery. EMF of the battery? EMF of battery? That's the voltage of the battery. Is the voltage of the battery. There's a whole lot of language to learn here, and little by little, we're going to learn it. So, what's the lesson for today? Number 1, Volta, Alessandro Volta, was shocked to discover electricity. Number 2, ammeters are connected in series. Number 3, voltmeters are connected in parallel. They have 0 resistance. They have infinite, well, very, very big compared to the resistance here. So this might be, this is 6 ohms. This might be 5,000 ohms. So it's huge compared to this and has very little impact on the circuit. This has very little impact on the circuit. Okay, so any questions? Fire the questions at me. I haven't had any questions from year 9 yet. I'm either teaching it brilliantly or you're not doing it, which is not true because I can see the hits on the videos. Or I'm explaining it absolutely fantastically, or you can't be bothered, or something else. So I'm going to give you a bit of an assignment after this. So have a good look at this, and then I'll give you an assignment, and let's see how you go in that. See ya.